So this video is a review of how to solve quadratics. You've learned two different methods in the past. One is factoring the quadratic to solve it. The other method is using the quadratic formula to solve. So either way, when you're solving quadratics, the very first thing you want to do is to get the quadratic written so that it equals 0. So very first thing, you want it to be written as ax squared plus bx plus c equals 0. That's the first step regardless of your method of solving. And then after that, you can use one of these two methods depending on the instructions, depending on what the numbers look like, that sort of thing. So when you factor to solve, you might have something that looks like this, x plus a, binomial factor where the x does not have a coefficient, or you might have something that looks like this, bx plus c. So when you factor to solve, we use something called the zero product property. And what the zero product property says is that when you multiply two numbers together, the first set of parentheses represents one number, the second set represents another number. When you multiply two numbers together and the result is 0, what that means is that the first number might have been 0, or the second number might have been 0, or both of them might have been 0. And so that's how we actually go about doing this solving, is we assume that one factor equals 0, or the other factor equals 0, or both. All right, so we're going to assume that one factor or both equals 0, because that's how it works when you multiply two things to equal 0. That's what the zero product property says. So the first thing we do with that is we take the first factor, x plus a, we set it equal to 0, and we solve for x. So to solve for x, I'm going to go ahead and subtract a to the other side. And so I get x equals negative a. And this part is probably what you remember the most from this, that if x equals positive a, or you have x plus a in the factor, then x equals negative a is the solution. A lot of students remember, oh, it's just the opposite sign. What students forget about that is how to handle this situation. So over here, we're going to do the same thing. We're just going to take the factor, we're going to set it equal to 0, and then we're going to solve for x. So I'll go ahead and subtract the c over to the other side. I get bx equals negative c. I'll divide the b over, and I get x equals negative c over b. So if you can't remember what to do in this situation, I will refer you to these notes. So it is still the opposite sign, it's just the opposite sign in fraction form. All right, so the first example problem is a trinomial set equal to 0 already. The a value equals 1, so this is a pretty typical factoring problem. We are just looking for two numbers that multiply to negative 28 and add to negative 3, and the two numbers that do that would be negative 7 and positive 4. So in the parentheses, I'm going to write x minus 7, x plus 4, equals 0. So I'm going to write my factored form, and then I can go ahead and do my solving. The opposite sign of negative 7 is positive 7, so I'm using this method right here. The opposite sign of negative 7 is positive 7. The opposite sign of positive 4 is negative 4. I do not want you to skip steps. Students who skip steps before they're very, very good at the material tend to get things wrong. So it is very common for students to go from this to this answer and tell me that their answers are negative 7 and positive 4 and get the answer wrong because they don't really understand what they're doing. All right, next problem. So this one does not equal 0 yet, which means that's where we have to start. So I'm going to go ahead and get everything over to the left side of the equation. So that's 0 now. So we got 10x squared minus 11x minus 8 equals 0. And since there's a coefficient with the x squared term, that means that this is a slide divide problem. So I'm going to go ahead and slide the 10 over to the -8. 10 times -8 is -80. So we're looking for two numbers that multiply to -80, but add to -11. So if I don't know those numbers off the top of my head, I'm assuming a lot of us probably don't, you can use your calculator to help you find them by doing -80 divided by x and then looking at the table. This is going to give you all the options that multiply to -80. As you can see, these are the ones that are adding to a negative number. So that's -79, that's a little bit too negative. -38, decimal, -16. There we go, that adds to -11, so those are the numbers that work. So we got 5 and -16 are the two numbers that add to -11. X plus 5, x minus 16. So I did the slide part. Now I'm going to divide by 10. You always divide by the number that you slid. I need to reduce the fractions. You always reduce if you can. 5 over 10 becomes 1 over 2. 16 over 10 becomes 8 over 5. And then from here, we do bottoms up. So 2x plus 1, 5x minus 8. All right. Now, this is where the second part over here kind of comes in handy. Both of these answers are fractions. So we know it's going to be the opposite sign, but it's going to create a fraction. So our first answer is -1/2. Our second answer is +8/5. And you can actually get the answers from over here. And the reason that we didn't just stop there is because that's not the correct factors. If you were to FOIL this out, this would not equal this problem. So if you're factoring to solve, you really should factor all the way. It should be correct. If you FOIL this out, 2x times 5x is 10x squared. 2x times -8 is -16. -16x plus 5x is the -11x, and then -8. So these are the correct factors. This is in the middle of the process of factoring, but it's not done. So these are the correct factors. They get there, but you can actually see them here a little bit more easily. Okay, so there's two examples of factoring to solve using the zero product property. The next method for solving a quadratic is the quadratic formula. So the quadratic formula is x equals -b plus or minus square root of b squared minus 4ac divided by 2a. And the number underneath the square root sign is called the discriminant. And the discriminant just tells us some interesting things about our answers. It helps us a little bit with plugging things into the calculator. So if your discriminant zeroes out, if this part right here disappears because it all cancels out, then you're not going to have plus or minus anything. You're just going to end up with -b over 2a. So this is going to give you one real root. If that happens, you're going to get one real root. If your discriminant is less than 0, so if you get a number here that's negative, then you're going to be doing plus or minus the square root of a negative number. And we know that if you try to square root a negative number on your calculator, it doesn't like that because you can't square root a negative number. So if this happens, you're going to get two answers because of the plus minus. There's going to be two, but they're not going to be real. They're going to be complex. Two complex roots. Okay, and complex roots have a portion that's imaginary and a portion that's real. So the portion that's real is going to be this portion because that's a real number, but this portion here is going to be imaginary. So two complex roots. If the discriminant is greater than 0, then that means that this portion right here is going to be a positive number, and then you're going to have two real roots. So one for the plus, one for the minus. Now, when you have a positive number here, there's two ways that can happen. You can have a perfect square. And if you have a perfect square, then you're going to get a nice number. Your answer is going to be rational. If you plugged it into the calculator, it would give you a fraction, a nice fraction, maybe a whole number. Well, I always think of any fraction as being kind of nice, but it'll give you a fraction or a whole number. If this number is not a perfect square, then it will give you an irrational number, which is just going to be some sort of funky decimal that it's impossible to write as a fraction. So either a perfect square and you get a fraction number or a whole number or something like that, or not a perfect square and then you get some sort of crazy decimal. All right, so let's go ahead and do 2 problems with the quadratic formula, and then that'll be it for the notes. So again, we always want it to equal 0 before we get started, just like when we were factoring. So with this one, we need to subtract the 4m to the other side. So we have 4m squared minus 4m plus 5 equals 0. And I'll go ahead and just say what A, B, and C are. You don't have to write them down every time. If you are good at recognizing what is what in the equation, then that's fine. It's important that you write it in order so you can recognize. So A is 4, B is -4, C is 5. So we have m equals -b plus or minus b squared minus 4 times a times c, all divided by 2a. And you'll notice I put b in parentheses because anytime you square a negative number, it has to be in parentheses. So let's go ahead and do some simplifying here. So negative of -4 is +4. 2 times 4 is 8. And then I go ahead and I just do the discriminant on the calculator. Notice that I'm not going to plug the square root in because I have the square root written on my paper. So I'm just doing the discriminant, which does not include the square root. It's everything underneath the square root. So my discriminant is -64. So anytime your discriminant is negative, let me backtrack a little bit. When you are solving a quadratic, you're picturing a parabola. And the solutions of a quadratic are actually the x-intercepts of the quadratic. They're the x-intercepts of that parabola. So if you have imaginary roots or complex roots, that means you don't have any x-intercepts. That means either the entire parabola is above the x-axis or the entire parabola is below the x-axis. So if we were to take this is a positive parabola. It doesn't have a negative sign in the front, it's positive. It's going up, so that means the entire parabola is above the x-axis. In this case, it has no x-intercepts. I can tell that because the discriminant is negative. So that's just something, that's why the discriminant is interesting, is it gives you some clues, and if you know enough to understand and interpret those clues, it can give you some information without looking at a picture of it. Okay, so this is where I put my calculator away. At this point, I can't do much else with my calculator. So I'm going to go ahead and do some more simplifying with this. The negative underneath the square root sign, my calculator would not have liked. It means that I should take the square root and make it positive underneath, positive 64, but I should put an I in the front, I for imaginary number. Now, we know that 64 is a perfect square. The square root of 64 is 8, so I'm going to go ahead and do that math. 4 plus or minus 8i. And then I also can see that 4 and 8, those numbers all are divisible by 4. And anytime I see that all of the numbers can be simplified, I'm going to go ahead and do that. So I can divide by 4, divide by 4, divide by 4. And it only works if you do it for all of the numbers. You can't just do it for these two. You can't just do it for those two. It's got to be for all of them. 1 plus or minus 2i divided by 2. That is my final solution for x. So I guess those are my fake x-intercepts that are invisible. All right, let's do the next one. Last one, almost done. Go ahead and add the 10m to the other side. So we have 3m squared plus 10m plus 4 equals 0. We have our A, our B, and our C. So for the quadratic formula, that's negative b plus or minus b squared minus 4 times a times c divided by 2a. So I'm going to go ahead and clean it up just a little bit. So for b, we got negative b in the front, we got 2 times 3, we got 6 on the bottom. And then I'm going to go ahead and figure out what my discriminant is. So I got 10 squared minus 4 times 3 times 4, 52. So this time my discriminant is a positive number. It is not a perfect square, which means that I'm going to get some decimal answers as I find those solutions, which are roots, which are my x-intercepts. So I'm going to go ahead and put squiggly equal signs here because I know these are going to be funky decimals, just because that's a 52 and not something like 49 or 16 or 100 or 121 or something like that. I know I'm going to get funky decimals. Okay, so we're going to try to type this in all at once. You should be doing this at home because I want to see if your calculator is capable of this. We want to make sure that we can type all these things in and actually get them right. So if your calculator has the updated operating system, it will be able to do this. If not, let me know and I will update the operating system for you. So you're going to hit alpha, the green button, alpha y equals, and this screen is going to pop up. We're going to choose number 1, n over d, numerator over denominator. And we're going to type negative 10 plus square root 52 over 6. It just makes it really easy when you can type exactly what it looks like on your paper. So the first solution is the decimal. I'm going to round it when I write it down on my paper because I'm only going to write 3 decimal places instead of all of them. Negative 0.465. Now I'm going to hit the up arrow. I'm going to go up and select that and press enter. And then I'm going to hit the back arrow and go back to that plus sign and write minus. Negative 2.869. There are my 2 solutions, the plus version and the minus version. And if I were to graph that, those would be my 2 x-intercepts.